Beginning in 2004, the MB900 coolant pump was redesigned. It is still cast iron, but the pump shaft and bearing are larger. It has a new heater core connection and thermostat housing. It still utilizes two thermostats, but they are now mounted on the top of the pump. The engine coolant temperature sensor is incorporated in the same housing with the thermostats, along with a vent fitting and a connection for coolant return from the upper EGR cooler assembly. Coolant flow rate for this pump has increased to 80 gallons per minute at rated speed. This new pump is also bolted to the front of the engine and is driven by the crankshaft pulley and a belt. No paper gasket is used to seal the pump to the engine block. A preformed rubber seal on the front face of the coolant intermediate plate seals the pump. The EGR cooler dissipates heat from the recirculating hot exhaust gases before they are delivered to the combustion chamber. Coolant circulating in the core cools the hot gas that passes through it. Coolant from the water pump flows through the lower EGR cooler bundle, through the EGR valve housing, and into the upper EGR cooler bundle. Coolant flows out of the upper bundle to the thermostat housing. The EGR cooler is composed of two cooler bundles of different lengths, housing stainless steel tubes that circulate coolant. The unequal lengths of the tubes and bundles reduce thermal shock within the cooler. This configuration limits contraction and expansion of the cooler bundles. A leak path has been designed into the EGR rotary valve mounting face and EGR cooler to allow coolant to escape externally. The mounting face and cooler have also been modified to prevent coolant leakage from leaking into the exhaust gas. A de-aeration fitting is attached to the coolant return line from the EGR cooler to bleed any air that might get trapped in the coolers. There are two thermostats in the MB900 series engines. They are full blocking type mechanisms. Preset, temperature-activated thermostats open and allow coolant back into the top of the radiator. Both of the thermostats have air vents. One is a built-in check valve, and the other is an orifice to vent air that may get trapped in the cooling system. Both thermostats use an O-ring seal. All of the 900 series engines employ automatic heavy-duty belt tension devices. They are located on the oil filter housing. Block heaters are used to warm the coolant when outside temperatures might otherwise cause freezing. The heaters are electrically powered and generally plug into domestic electrical outlets. An optional 1,000-watt, 120-volt block heater used for temperatures below minus 10.6 degrees Celsius or minus 13 degrees Fahrenheit is available for the 900 series engines. Provisions for this heater are made on the right side of the block. A freeze plug in the top right rear side of the block must be removed for the installation. Maintenance best practices. Regular and frequent inspection of the cooling system for leaks, obstructions, loose clamps, or any problem that might affect the system is the best way to avoid malfunctions and poor performance. Inspect clamps, pipes, belts, fasteners, and mating surfaces regularly. Coolant concentration should be maintained at the 50% level at all times and topped off when necessary. To avoid damage to the cooling system, only approved corrosion-inhibiting antifreeze is used in the MB900 cooling system. Approved antifreeze must comply fully with the requirements of the Truck Maintenance Council, or TMC, as listed in this chart. Some causes of above normal coolant temperatures could include coolant levels that are low, a loose poly V-belt, A faulty coolant temperature sensor or gauge. A radiator that is damaged, blocked, or dirty. A damaged or faulty coolant pump. A damaged or faulty thermostat. An inoperable or faulty fan. Or coolant that is over-concentrated. Coolant temperature below normal can be caused by a faulty coolant temperature gauge, a faulty coolant temperature sensor, a damaged or stuck open thermostat, or a malfunctioning fan. Loss of coolant can be caused by an external coolant leak, a radiator cap leak, a damaged air compressor head, a damaged cylinder head gasket, a cracked cylinder head or block, an EGR system leak or a leaking top tank. Engine oil in the coolant can be caused by cylinder head gasket damage, a damaged oil cooler, an internal coolant leak, a cracked cylinder head or engine block. The coolant level should be checked regularly and at a temperature of 50 degrees Celsius or 122 degrees Fahrenheit. Before adding coolant, check that the concentration in the system is at 50% antifreeze by volume. If it is below this level, the coolant should be drained enough to allow the addition of antifreeze to check the system's hoses, pipes, and connections for damage or leaks. The object of this exercise is to place each of the four